Today we are looking at solving logarithmic equations where you have a logarithm on only one side of the equation. And again, don't forget to count up the number of brain and hand sightings for the raffle. Okay, so the property is if log base a of y equals x, then y equals a to the x. Basically, they're just saying you can do the log ride, you can change forms, and do a to the x equals y. Basically, when you are stuck, change forms. You always want to isolate the logarithm first. So like in number 15 and 16, there's going to be some stuff that we have to do first to get the log by itself before we change forms. So isolate the log and then change forms. This one, there's nothing multiplied in front, there's nothing added or subtracted after. This log is isolated, so start with your base and change forms. 2 raised to the negative 1 equals x. And then all you have to do is punch that into your calculator. So punch in 2 raised to the negative 1, or hopefully if you remember your properties of exponents, you remember what this is. It is 1/2 or 0.5. It does say check for extraneous solutions. Just like yesterday, you have to check each solution to make sure that you're not creating the log of a negative number, because you can't put negative numbers into logarithms. Remember, the graph of a normal logarithm has a vertical asymptote at x equals 0. So this graph is getting closer and closer to an x value of 0, but it can't be 0 and it definitely can't be negative. The domain, the x values for logarithmic functions, are x is greater than 0. So you have to have a number inside the log bigger than 0. 0.5, that's positive, it's good, that one's good. Number 14, there's nothing outside of the parentheses added or subtracted, there's nothing in front, so this log is by itself. As you go to change forms, remember, if it says ln, that means log base e. So if you need to draw a little e in there, or even if you need to rewrite it, log base e of x plus 22 equals 3, whatever works for you. Do the log ride. E to the third equals x plus 22. You can punch e to the third in your calculator. Remember, e is above your ln button. Wherever your ln button is, e is directly above that. So in this calculator, I would punch in second ln to get my e, and then raise to the third. E to the third is about 20.086. And then finish solving by subtracting 22 on both sides. So our answer is negative 1.9 approximately. You do need to check this solution to make sure that it doesn't create a negative number inside the log. So if you took this number and added 22 to it, would it be a negative number? No, it would not. So that is our solution. Number 15, we start getting into an instance where we need to do something before we change forms. We always add or subtract when we're solving equations before we multiply or divide. So our first step will be to subtract 7 on both sides. And then we divide both sides by 2, because this is 2 times ln, so divide both sides by 2. And I'm keeping the parentheses around that negative x just to contain that negative x. 7 divided by 2 is 3.5. Remember, ln is log base e. Now we're stuck. X is stuck inside the log, so change forms. E raised to the 3.5 equals negative x. So punch in e raised to the 3.5. That is about 33.115. And to get rid of this negative in front of the x, you divide everything by -1. So our final answer is x equals -33.115, or -33.1. Remember that we need to check. So if you plug -33.1 in here, because of this -33.1 would become a positive number, and that would make the number that we're putting into the log be a positive number. So this answer is absolutely fine. I would like you to pause the video and try number 16 on your own. I would start by subtracting 15 on both sides. And then I would divide both sides by 2. And now I'm stuck. X is stuck inside the log. You can't divide by log base 2. If you divide by a log, you have to divide by the whole log, including the number inside of it. Log isn't like it's not like a number, it's an operation. So that x is a part of it. You can't just divide away part of it. So instead, we change forms. Woo! 2 to the 8th equals x. To do 2 to the 8th in your calculator, 2, caret button, raise it to the 8th, 256. Check. If we plug 256 into the log, that would not be a negative number, so we're good. Number 17 is where this gets a little bit more complex. Just like yesterday, we might have to condense the logs before we continue on. So since there's 2 logs on the left, we need to condense these logs before we do anything else. So addition between the logs means multiplication. So this is log base 2 of x times x minus 2 equals 3. Now we're stuck. Now we need to do the log right. Woo! 2 to the 3rd equals x times x minus 2. 2 to the 3rd, we can plug that into the calculator. That's 8. We need to distribute. Anytime you have x squared and x in an equation, we need to get one side equal to 0 so we can factor and solve. So we're subtracting 8 on both sides. When we factor, we're looking for 2 numbers that multiply to give us -8. Those same numbers need to add up to the middle number, -2. Think about ways you can multiply to get 8. You can do 1 times 8. You can do 2 times 4. If I used 2 and -4, those would add up to -2. 2 times -4 would multiply to give me -8. So plus 2 and minus 4. Then solve. Your solutions would be -2 and +4. We need to check these to see if they would create a negative number inside the log. So put -2 in here. -2 would definitely make this first log have a negative number inside. -2 minus 2, that'd be another one. So that is an apparent solution that doesn't actually work. So that's an extraneous solution. Log base 2 of 4, that's fine. Log base 2 of 4 minus 2. 4 minus 2 would be 2, positive number. That one is fine. I would like you to try number 18, except to make this factorable, we're actually going to change this. We are going to use log base 4 of x plus log base 4 of x plus 3 equals 1. So basically the same thing except log base 4 instead of ln. So get that written down and give that a try on your own. Pause the video, try that one on your own. First step, compress. Log base 4, compress, condense, whatever. Log base 4 of x times x plus 3 equals 1. Second step, change forms. Woo! 4 to the first equals x times x plus 3. Multiply out, compute, whatever. 4 to the first, 4. Distribute. You got x squared plus 3x. Now we need to get 0 on one side, so we're subtracting 4 on both sides. So we're looking for two numbers that multiply to give us -4 and add up to +3. The only ways to multiply to get 4 are 1 times 4 and 2 times 2. If I had a -1 and a +4, that would fit that scenario. So x minus 1 and x plus 4. Now solve. Our x values would be +1 and -4. Check your x values. Log base 4 of +1, we're good. 1 plus 3 is 4, so that log would be fine. So x equals 1 is a solution. -4. If you put a -4 in that first log, that would be a negative number. That's not okay. -4 plus 3, that one is also not okay. Now I know it looks like the negative answer is usually the extraneous solution. Often that does happen, but it's not a definite. You need to check, because if this had been log base 4 of -x and x plus 5, then an answer of -4 would have worked just fine. So yeah, it tends to be the negative solution is the extraneous solution, but don't just assume that. Still try it out and check. I also want to show you the calculator trick so that you can check yourself. I wouldn't use this as a solution method, but you can check yourself. So on this one, if I put log base 4 of x plus log base 4 of x plus 3, put that into y1, and then in y2, put the other side of the equation, 1, and then watch it graph. So in blue is the left side of my equation, and then in red, y equals 1 is a horizontal line. Notice they cross at an x value of 1. At an x value of -4, this blue one doesn't exist, so -4 cannot be a solution. 1 is a solution. So this is a great way, if you have a graphing calculator or if you've borrowed one, to check yourself and make sure that you have done the problem correctly and that you've eliminated the extraneous solutions.